Welcome back, grade 6, to Nelson Math, chapter 9, multiplying decimals, getting started. For this chapter, we are going to be estimating products involving decimals and explaining strategies. We're multiplying decimals by tens, hundreds, and 1000s using mental math. We will multiply whole numbers by numbers with one decimal place, in other words, numbers to the 10th. Multiply whole numbers by 0.1, 0.01, and 0.001. And we're going to select an appropriate multiplication method. Of all the different choices you have, you're going to have to be a critical thinker and choose the best one that is for you. As we always do for getting started, let's do some review here. So number 1 is asking, what decimal does the shaded area of each model represent? For a question like this, whenever we have to look at a decimal, fraction, ratio, rate, whatever we're talking about, we must always ask ourselves, what is the 1? What's the 1? The O-N-E. What's the 1? If we don't have that, we cannot answer this question. So for this 1a, right here, we're going to say that the 1 is this entire large cube. So if this entire large cube is a 1, we have to be able now to chop it up and to see what the smaller numbers are. So if this is 1, then every one strip like this, every one strip, horizontal or vertical, would be 1/10, because we can fit 10 of these strips into this gigantic structure here, which is the 1. So that would mean one strip would be 1/10. One square, one of these small squares that is inside our large square, that would be 1/100th, or a hundredth, or 1/100, because I could fit 100 of these into my 1. I'm cutting them up into 100 smaller pieces. And if you can count the number of minuscule rectangles inside my square, there are 10 of them. For this question right here, there are 3 red slips, 3 red rectangles. So for this question, our fraction or decimal would be 0.003. I could also write this as a fraction of 3 over 1000. And the reason I can write it as a fraction is because out of 1000 total pieces, 3 of them are shaded in. So 3 1,000ths. And if we go back to our decimal, this is 0 ones, 0 tenths, 0 hundredths, and 3 of the thousandths. Let's go to B now. So for B, if we say that the large square that I'm outlining now is a 1, then we can rewrite this one as 0 ones, and we have 2 strips, 2 big strips here, or 2 entire columns. That means 2/10ths, 2/10ths right there. And we have 1 full square over here, and that would be the hundredth. So that would be 100th. And we have 2 tiny slips inside the square. So that would be 2. In other words, we would have 212 red little slips over 1,000 total little slips. However, that would be if I call my entire square a 1. There are different answers to this if you choose to make, and you make clear what you've chosen to make as your 1. We'll discuss this further in class, but if you look down here for number 2, we're going to give an example of what that means. So we're going to see how this pans out. So let's do letter C here quickly. Once again, we can count our columns of tenths. We have 0 ones, and we have 4 tenths, 1, 2, 3, 4 full columns. We have 3 of our smaller squares, and there is nothing else that's shaded in. So that would be 430 of our 1,000 squares have been filled in. So this is a little bit different than the other two in that we don't have any digit in the thousandths column, but there is still a zero there. We have 0 thousandths. And if we were to count all of these very, very, very small rectangles inside the square, there would be 430 of them. 100 here, 100 here, 100 here, 100 here. That's 400. And then 10, 20, 30. So that's why it's 430 and not 43, not just 43. This is an example of what I'm talking about for number 2, where you must define your 1. That has nothing to do with the question we're being asked for number 2, but we do it subconsciously. We do it automatically. Number 2 is asking, what multiplication does the model represent? Here's our model right here. However, the 1 would be this one small square here. That's my 1. And I know that because this larger square has been labeled as a 100. If this larger square is labeled as a 100, then that definitely means that this long rectangle must be a 10, because you can fit 10 of these rectangles into one of these 100s. And that means that one of these small squares that are right here, I could fit 10 of these into one of these. So 10 of these small squares into one of these long rectangles. So that means I could fit 100 of these into one of these larger squares. So that's 100 of these smaller squares into one of these larger squares. And I'm only defining the term there. That doesn't have anything to do with the question because we are reviewing what multiplication looks like. I'm just showing that to you because it is important for every question you do. You always ask yourself, what is my 1? Because you've been learning ones since probably since you were about 1 year old, 1 or 2 years old, you probably just take for granted that when you are working with whole numbers, 1 is 1. That is definitely true. But now that you're in grade 6, you have to ask yourself, what is my 1? So there's a multiplication statement here. It's just in pictures. So we have a number of different groups. Where are my groups? Here's one group. Here's a second group. Here's a third group. And here's the fourth group. So I have 4 groups of what? This is 100, 200, 300, 10, 20, 1, 2, 3, 4. So this is 324. So the multiplication that this model is representing is 4 groups of 324. Here's one group of 324, group 2 of 324, group 3 of 324, group 4 of 324. And that's how I got my 4 times 324. So, 2b, how many groups do we have here? We have 1, 2, 3. That would be 3 times, how big is each group? Each group is 100, 200, 300, 1, 2, 3, 4, 5, 6. I should say that there are no tens here, so it is 306. And we can rewrite this as this, and that would be that particular multiplication model. For number 3, we're doing a bit of estimating now. I'm only going to estimate the first one. So if we look at 6 times 5.2, 5.2 is very, very close to 5. So I could estimate this as 6 times 5. And 6 times 5 is 30. So I'm going to leave the 30 right there. However, 6 times 5.2 must be bigger than 30 because I could rewrite this as saying 5.2 plus 5.2 plus 5.2 6 times. This one here is like saying 5 plus 5 plus 5 6 times. Well, I'm short of 5.2 every time. So this 30 is less than what our calculated answer is. We know that for sure. Let's look at 4a here. 4a is asking for a calculation. So this is 6 times 303. We have many different ways of doing this. So we could add 303 up 6 times. So 303 plus 303 plus 303. We could do that. That will work. Or we could use some mental math, and I could take my 6, and I could say 6 times 300, and then I can add that. I can add that to what I haven't yet multiplied. So this is like saying 6 groups of 303. So here I have 6 groups of 300, but I'm missing 6 groups of 3. I didn't include those there. So 6 times 3. And I can add all these up. So 6 times 300, we learned from a previous chapter, 6 times 3 is 18. And then there are 2 zeros, so add 2 zeros. And now I'm going to add my 6 times 3, which we know is 18. So our calculated answer is 1,818. Let's do B. 5 times 412. And we're doing the same thing here. So we could decompose the 412. If we want, of course, we can add it up. I could write it out this way. 412 plus 412 plus 412 plus 412 plus 412. So all I did is I wrote it out in expanded form. Now I'm going to add them up, but I'm going to add them up starting with the hundreds. 400 plus 400 plus 400 plus 400 plus 400. You could add them, but a fast way of doing that would be 5 times 400, which is 2,000. But I haven't yet added up all of my 12s. I haven't added those yet. So 12 plus 12 plus 12 plus 12 plus 12, 5 times. That's like saying 5 times 12, which is 60. So 5 times 412 is 2,060, like that. And for our last one, we're going to do 4F. That's 100 times 0.56, like that. And this is like saying take 100 groups of 5/10, 6/100ths. So I could rewrite 0.56 plus 0.56 plus 0.56. I could do that, but we're not going to. I could add them all up, and I could say this is like saying 100 times 0.5, and 100 times 0.5 is like saying 100 groups of a half. So if I have 100 halves and I put them all together, I would end up with 50. So that's my first part. I could have also, for example, moved the decimal place over twice. I could do that too. So my 100 times 0.5 is 50. But now I have to add that to my 100 times 0.6. So 100 times 0.06. And this is the same idea. So if I have 6/100ths, as we learned in a previous section, if I have 6/100ths and I do 100 times 6/100ths and I put them all together, that's 6. Right there. So once I add them up, I could say 50 plus 6 equals 56. And if you were looking for a pattern here, once again, you could say that if I'm multiplying by 100, I move the decimal place over twice. So move it over 1, 2. So our answer is 56. Number 5. 5 is asking, choose 2 calculations to perform using mental math and then calculate. We will do A and B. So 6 times 427. We could use any of the methods that we used up here. They're all good. They're all valid. What's important is that you can justify how you did it. So in my case, I may want to say I'll take 6 times 400, and then I'll take 6 times 20, then I'll take 6 times 7, and then add them all up. I could add them all. So I could do this part very easily in my head. 6 times 4 is 24, but there are 2 zeros on the end of it. And then I'm going to add that to 6 times 2 is 12. There's a 0, so add a 0 on the end of it. And lastly, 6 times 7 is 42. So I decomposed my 6 times 427 into 6 times 400, and I added that to 6 times 20, and then add that to 6 times 42. So I can add these all up now. 2,400 plus 100 is 2,500. 2,500 plus 62 is 2,562. And for our B, 6 times 15. Once again, I'm going to decompose the 15 into a 10 and a 5. So I could say 6 times 10 and 6 times 5. And if I add them up, 6 times 10 is 60. 6 times 5 is 30. So that would be 90. So I just pulled the number apart. This is not the only way of doing it. If I wanted to, I could have, for example, done 15 added up 6 times. I could have done 15, 30, 45, 60, all the way to 90 if I want to do that too. Those are all valid ways of doing it using mental math. So there we go, our review. Please be comfortable with all of these concepts, particularly showing multiplication in different ways, because it will make this unit go much, much, much easier if you understand what multiplication means, instead of just being able to calculate it. Thanks, everyone. Have a great day.